The middle of projects is always a bit dumb. We're not where we started, but we're also not where we're going. We're just in the middle. I'm working on the Eureka gear cutter tool from this book about, shockingly, gears. And so far I've made this, a useful-ish device, which basically just spins, but also makes these ear-wateringly delicious clicking sounds. There's so much more to this thing though, and even more than that to being able to properly use it. But I'm getting ahead of myself. We have the whole middle to cover, so let's focus on making this thing a little useful-er. In case I glossed over it a bit too fast, this Eureka gear cutter tool is a contraption that should allow me to make my own gear cutters, so that I can make my own gears, so that I can say I made my own gears. It may also have something to do with this machine as well, but that's way down the road. Let's just pick up where we left off last time. Like most big hairy projects, it's best to start with the hardest part first, and the mandrel is definitely going to be the most challenging, but not this one, this one. Naturally, I've been making changes as I go based solely on hunches. Hunches about a tool I've never actually used, but I digress. While it seems like a simple shaft with some different diameters, if you look a bit closer, you'll see that it's a bit eccentric in nature. There are 3 different axes through this part. One for this diameter, these 2 big ones are on another, then everything on this end is on a 3rd axis. So the forejaw is going to be earning its keep on this part. After truing up the stock, I'll immediately untrue it with 2 opposing jaws to approximately 0.168 inches, which actually needs to read twice this value on the dial indicator. Trust me, forgetting this is a mistake you only make once. With a little emotional support from the tailstock, we can start on some of the more punishing operations. Interrupted cuts like this are generally really hard on both the tooling and the part, so I'm going to use this round insert with a much larger radius. This lets the cutter more gradually engage with the metal as it comes around, rather than impacting the cutter all at once and shattering this brittle carbide insert. Here you can actually see it without anything moving at all. The cut starts here, then gradually builds because of the radius of the tool. In non-machinist talk, this is more of a swoop 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 rather than a chunk chunk chunk, if you know what I mean. Let's keep moving. I've finished this end completely, but only got to start on the rest of the length. Why I did this will make sense in about 38 seconds, so let's part this off. Now this is where things get messy. Remember, these diameters have different center axes. So to keep things square, that's exactly what I'm going to use. A square, call it block. But this only works if I get the part straight in the block as well, or in this case, just straight-ish. It's important, but I have some wiggle room, so no need for indicators. Now this whole ensemble goes right back in the lathe, with a little protection on the jaws this time. And here's why I cleaned up that other end, just so that I can use it to indicate it back true. Pays to think ahead. But that isn't to imply that I'm an expert at it. Case in point. I have to face this end to the correct length, but now I have no idea how long it is because I crammed the other end down in this collet block. Oh, I do know the distance to this face though. So I'll clean up the other side of this flange thingy, measure that thickness, scooch over that amount, zero the DRO, and crash the lathe.
Fuck me. I saw it right as I threw the switch. I was like, that's gonna fucking crash. Nice.
I think that's my sign to call it a day. In fact, I'm pretty excited to turn in for the night because of our new sponsor, Helix Sleep. Helix Sleep is an online mattress store that offers customized sleeping solutions shipped right to you. And with 20 unique mattresses, they're sure to have something for even the pickiest of slumberers. even big and tall sizes for the robust among us, and kid sizes for those of us still on our way. But you don't have to just guess which mattress is best for you. That would be like choosing your spouse from a photo book. So like any proper dating app, Helix has a compatibility test called the Sleep Quiz. They ask you questions about your physical parameters, your normal sleeping position, whether it be the Superman, the vampire, or the scared and alone, and how beat up you typically feel after a hard-fought night of sleep. They'll even make these considerations for a two-person mattress to find the best compromise for both sleepers. In the case of myself and I, that ended up being the Helix Dusk mattress. Now, I'm not going to lie to you. You literally just watched me unpack this thing, so I don't have a long-term report. But first impressions are really good. This is definitely unlike any mattress I've tried before. The combination of the foam top with the springs underneath really seemed like it's going to be comfortable all night long. I also went with the optional Glaciotex cover because things tend to get hot in here, if you know what I mean. Now I realize buying a mattress sight unslept may be risky, and I have the same reservations honestly. But Helix is smart and includes a 100-day risk-free trial period. And if you're like me, your first thought is probably, how the hell am I supposed to get this back in the box? Well, you don't. Helix will send some folks to take it away for you to either be recycled or donated when possible. This alone tells me they have a lot of confidence in their product, not to mention the 10-year warranty they include on all of their mattresses. So yeah, I'm pretty optimistic that I'll be getting some solid rest. If you're unhappy with your mattress, take Helix's sleep quiz and give one of their mattresses a try. Helix is actually running their 4th of July sale right now, so it's the perfect time to upgrade with 30% off an Elite or Luxe mattress with 2 free pillows, or you could get 25% off site-wide. Use my link below or go to helixsleep.com/inheritance to take advantage of this limited time offer. Thank you Helix Sleep for sponsoring this video. All that setup and heartbreak was basically just to get this center drill in the end, which I don't even get to use because it's time to work on the eccentric stuff. And herein lies the advantage of the collet block. Since each of these offsets are at right angles to one another, I'm pretty much guaranteed any shifts I make with the jaws will also be at right angles to one another, or at least really close. So this first offset of 30 thou is just a matter of shifting jaws 1 and 3. And I hope it's obvious now why I can't use that center drill from before. But it'll have a purpose later on, so hold your horses. Like most single point threading, I'll check the progress with the 3-wire method. But that doesn't necessarily guarantee a good fit with the nut that will go on here. So over on the mill, I'll make one real quick. Don't worry, this isn't the actual nut I'll use. Of course I'll do better than this. But I need the lathe to make that, and well, it's occupied. Perfect. After turning down the rest of the shaft, I'll do a light honing to perfect the fit with the spinny clicky contraption. Oh, sexy. Okay, one more offset for the largest diameters on the part. This time shifting jaws B and D. And here I just turned down past that carbide destroying mistake. Add another smaller diameter. Then of course add some chamfers on here. Then boom. Boom. One mandrel finished. And so far it looks like everything came out right. Of course it's hard to tell without seeing this thing in action, but a lot more parts to make before then. So let's go ahead and make the real nut that's supposed to go on here. The original design calls for just one nut, but I don't like that for a multitude of reasons, so I'm going to make 2. And this seems like a perfect opportunity to maintain the bronze accents I've been adding throughout this build. I definitely prefer to single point cut these threads, but my smallest tool isn't small enough, so I'll have to tap these by hand, hence using the tap to make the test nut I did earlier. The only trouble with tapping this is I can't be sure that the threads they make are truly square to the faces of the nuts. I do have a fix for this though. Okay, like I said, the threads may or may not be square with the faces of the nuts, so rather than play the guessing game, we'll just make them square, with something like this. A mandrel. Now my magical snap didn't just make this appear, but also made these threads perfectly true with the lathe. Now as I screw these nuts on here, I know that their threads are straight as well. So it's just a matter of bouncing through the faces of each nut to square them up with their threads. Square is good, but it's also boring. So over on the mill, we'll make these more nuttier, with the help of the collet block, of course. Almost done. My obsessive chamfer disorder can't allow these to be finished parts, so it's back to the lathe. That's the stuff. Okay, now why did I make two? Well, the first holds everything together, then the smaller holds the first in place. This is called a jam nut, and it looks great, except for one problem. When I grunk them down, now they don't line up. Unacceptable. But a quick pop in the lathe to skim down a few thou off of one face, and now these clock together perfectly. With that, now I have a fine looking spinny clicky doodad. But this is clearly imbalanced. I'm going to need the second clicky to even this out. So let's work on that next, starting with the ratchet plate. I don't really want to go through the process of squaring up a bunch of stock to make this, but maybe if I pray to the material bins of gratitude hard enough. Hey, it worked! Okay, let's jump into the fun stuff, starting with some holes and slots. We love a chamfer. Time to open this big guy up even more. And this next part might be a little, well, I don't think I even need to say it at this point. Sorry, I know this joke is getting a little... After a little funny business with the insert, I can also chamfer this big guy, then flip it over and do the deed on the other side. I'll relocate the part with a gauge pin and the spindle, then continue the glorious chamfering action. Okay, that's all the penetrations, time to work on the perimeter. And that's a perfect job for the honkin' rotary table that's been hanging out in the background of the mill this whole time. After finding the center of the table with the coaxial indicator, I'll pop the part down and use a gauge pin to locate on the end of the slot. This gets it centered, but who knows if we're square. So I'll tram along this edge, spinning the rotary table a little bit until there's no more movement in the indicator. Then of course reset the table's dials. Now for some chips to go with this fish. I'm using a roughing mill for the heavy lifting, first milling straight along here, adding the round on the end, and finishing straight again on the other side. The roughing mill doesn't leave the best finish though, so I'll do that all again with a finishing mill. And while we're here, might as well add the most important features. Alright, now for all the big rounds around the big hole. Don't exactly have a gauge pin up for the job, so it's back to the coax. First tapping the part into place, another tramming job with the indicator, and I think you can figure out the rest. Now I'll admit, I cheated a bit at this point. The drawings for this part didn't include much in the way of angles. And by that I mean literally nothing. So I went ahead and modeled this part so I can project more angles than I actually need. The last bit is this little dude on the end, which is around this threaded hole. So what better way to center it than to use the very tap that made that hole. Bada bing. Looking great, but now I have chamfers to do on the other side. I could go through the trouble of setting everything up again, upside down, or I could just... I think that's perfectly acceptable. With that in place, we're getting really close to some more clickety-click noises. So let's make the bit that will sing those sweet serenades. The ratchet pawl. This is basically identical to the pawl I made in the last video, so just enjoy. Alright, well it wasn't without hiccup, we made it. But it isn't ready for its performance yet. Not without the backing tracks. And by that I mean the pivot screw that holds this in place. This is a simple enough part with a few different diameters on one side. One of which gets threaded with the die holder. Then after parting it off, the other side gets a similar deal. Easy peasy. Where there are threads, there are usually nuts, so take a wild guess what's next. And of course I'm using bronze on this one too. Can't forget the chamfers on this one either. And after parting this off, I'll use this nifty pre-made mandrel I found to hold the nut for finishing. Beautiferous. The nut and the pivot go on the assembly like this, but you can see there's a suspicious looking gap here. Well, that's because we have one last piece to make. A spring. And unlike the one I made last time, this spring actually needs to look the part. To do that, I'll need a side project. So what does this mysterious piece do? Well, it's a spring-forming mandrel. Lots of mandrels in this video, huh? But this one's the coolest by far. With the help of this clamp I stole off of one of my other tools, I can secure a bit of spring wire in here, and then wrap the wire around the mandrel to form the coils. But that will only work if I can keep the wire tight. That's where this masterfully crafted bit of kit comes in. Between these precision machined boards, I can feed the wire and fasten it tight with these coarse-pitched helical inclined planes. This keeps tension on the wire so that it wraps tightly around the mandrel. And bingo, we have a torsion spring. This one looks a bit rough, but it was just a test. Even though I kept the wire very tight, it's always going to have a bit of spring back. In this case, about 33 thou on this inside diameter. So I need to make the mandrel even smaller by proportionally that amount, or about 30 thou smaller. I'll also file a bit of a lead-in to smooth the transition from the flat to round. Okay, let's give this another go. Just a hair oversized, but that's pretty much perfect for a little clearance room. And after a little trimming and more forming, I get this, which I think is not too shabby for a first attempt at a torsion spring. Let's get it in place. Oh yeah, that is so good. A proper double spinny, double clicky Eureka tool. But something isn't right. It ratchets fine like this, but in actuality, all the spinning should be coming from this eccentric mandrel we made earlier. The mandrel ends up pushing this ratchet pawl, which in turn rotates the indexing sleeve, but you can see it doesn't push it far enough for the ratchet pawl on the other side to engage. I spent a while poring over the drawings and verifying the measurements of all the parts when I noticed something small. This particular dimension on the ratchet pawl in question is listed as nominal, which in machinist terms means this number is bullshit, just make it work. So that's exactly what I'm going to do. There we go. Clicking when the clicker should click. Perfect. I think we're finally ready to see what this thing does. In action. And like most things I get excited for, I'm going to bring in the head engineer to share in the moment. How's it that I turned that AC off like literally 30 seconds ago and I'm already sweating?
It's the placebo effect. Head engineer? Are you saying I'm the head engineer? I don't think...
That's what I called you.
Between the two of us, I would much rather fly in a plane that you designed than one that I designed. Okay, mine don't look pretty. Satisfied with that?
Yeah, yeah, that works.
I didn't behead you.
You did not behead me.
Ooh. Your hole's a little off center here.
It's supposed to be. Why is it not doing it? There we go. Are you impressed?
I am impressed that you made a lot of metal look like different metal.
How about the colors?
The colors are beautiful. The colors are quite an Inheritance Machining signature. You can see my Tootsie stuff. Don't look at them. I know I'm not wearing shop-approved shoes, but...
Well, you're not doing shop-approved things, so...
Oh, you have another spring.
Yes.
You made this spring, you made that spring.
I showed you that spring. I showed you making that spring. Well,
I
showed you how I made that spring.
We have some of that footage.
We have a whole bunch of footage from that.
Inserted here.
I want you to see this. So
I know you want me to see this, but
why don't you come over here and look? The camera's set up.
I'm looking at the camera.
I want you to see it in real time. All right.
Oh, wow.
Shut up.
That is very impressive, though. It looks like a slow motion version of the How It's Made springs.
So I could turn the lathe on and it would be like the real How is it made springs.
That is excessively impressive. Organic tool holder is very nice, too.
Yeah, I didn't show how that's made because we don't do woodworking on this show.
And we're back.
And we're back. Okay. Doesn't this do a wobble spinny?
It does a wobble spinny.
Well, show me what it does.
Yes, let's set it up.
Okay.
So
you got a pointy in the chuck.
I got a pointy there and a pointy there.
Well, yeah, but that pointy's always there. Can I do the tailstock? Of course I can do the tailstock.
Easy. Okay, bring it in. Bring it in. So this pin goes in there, and that's what keeps this thing from spinning. Are you ready?
I believe I'm ready.
Throw that switch, mother.
I've never turned the lathe on.
Have you never?
I have never turned the lathe on. Does it go down? Like out and down?
It goes in and down.
In and down. Okay.
So you see how it's kind of whoop, whoop,
Yeah.
whoop, whoop.
That's extremely satisfying.
Isn't it beautiful? It's like one of the most complicated mechanisms I've made to date.
That is so cool.
I should stop putting my hand on the stupid chuck.
You should.
Oh, that's satisfying.
I'm so excited. I see a pen and I see a circle and I see things.
This simulates a gear blank that I'll put in here.
Oh, okay.
Sorry, not a gear blank.
A gear cutter blank.
This simulates a gear cutter blank.
Okay.
And this is the important part.
of why I'm making this. This is the path that it makes, okay?
Okay.
All right. Ready?
Yep. That is so cool.
Behind each tooth, it's angled back. That's what that is.
Oh.
So this is the Eureka form relieving gear cutter tool.
I love your demonstrations. You've done a couple of these.
This one was particularly inspired.
I would say that this slightly surpasses the rotary broaching of the Play-Doh.
Yeah. So it'd be
Very
much
interesting.
cooler to see it actually make a gear cutter, but that's a whole nother video.
That's an entire,
'Cause
yes.
I have to make the cutter holder, and then I've got to make all the cutter discs, because depending on what size gear you're cutting, you have to make different size discs, and they all have to be hardened.
Amazing.
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 Okay, so yeah, a bit more work before we're cutting gears, but nobody ever said this was going to be fast or easy. Remember, we're still in the middle. So tune in next time where we'll actually make some gear cutters, and if I'm being optimistic, might actually make some gears. As always, thanks for watching, and see you next time.
The starfish. The dead guy. The zombie. The roadkill. The Olympic diver. Sleeping's hard.